Assalamu alaikum. Okay, last time we ended up with the section of work energy, with the chapter of work energy power. And after that, we solved one paper of theory section in which we solved the starting question from the journal physics section. So now we are done with the journal physics section. Only we have to practice the questions from the past papers.
So, Assalamu alaikum.
Walaikum assalam. And there are also MCQs paper that we have to practice. We will practice that time to time with thermal physics section, because thermal physics section is not the lengthy section as like journal physics section. It only consists of 3 chapters. In the first chapter we only need to study about the kinetic molecular theory for solid, liquid and gases. Then we have to discuss the thermal properties, and in the third chapter we have to discuss the transfer of thermal energy, that what are different methods, what are different ways to transfer energy. So these are 3 chapters in the thermal physics section. And if we talk about the first chapter, so first chapter is related to kinetic particle model of matter. Okay, by name you can easily identify that it also consists of the same kinetic molecular theory that you already studied in your science or in your chemistry, that
In your
solids,
chemistry, yeah.
yes, that molecules are close to each other in solid, they are tightly packed, they have fixed shape, fixed volume, and then you compare with liquid, then you compare it with gases. So all these 3 states of matter are included in this section also. So first of all, you need to know about 3 states: solid, liquid and gases. And I hope you already know about the basic properties of solid, liquid and gases, right? So any confusion in the properties of solid, liquid and gases?
No, there's no
Because
confusion about
yes,
that.
because again you have to study that solid have definite shape, definite volume.
Yeah, yeah.
Solids
Same
can
stuff.
vibrate, they are not able to flow just like the liquid and gases. So the initial concept related to the 3 states.
Yeah, but so I do have one question.
Yes,
If in the exam it were to ask us to describe the like what do you call describe the differences and similarities and the properties of the different states of matter. So what
mm,
points do we include? Their shape, their volume, what else?
yes, and further there is a concept of intermolecular forces, the distance between them, just like if we consider the size of
Oh
the
yeah, no, I remember now. So arrangement, arrangement of the particles,
yes, their intermolecular forces,
what do you call space between the particles?
space between the particles,
What
or
else?
the third one is that in solids there is only a possibility of vibration rather than,
Movement of the particles.
yes, what was and how the particles are going to move, that is important.
Okay,
So these are
that's it.
basic
And then we
points.
have like shape
Random
and volume,
motion,
right?
yes,
Okay,
because in
thank
solids
you,
they
sir.
only vibrate back and forth, but in gases and liquid they are randomly moving. So these are some points that you can write in your difference between solid, liquid and gases. And further, the second thing that is included in your section is related to the change of states, because once you study about each and individual property of solid, liquid and gases, then there is a concept of if you want to change state from solid to liquid or from liquid to gas, so there are some process in our daily life that we already observe in our daily life, just like the process of melting, just like the process of freezing, boiling, melting. All these process are included in different states of matter. Yes, that was right. Okay, so
All right, sir.
basically if we talk about the changes of states, so in changes of states, if we talk about the melting first, so basically what do you think, that if we talk about the melting, so in melting states change take place from, what will be the change of state when we are talking about the melting point or the melting process, when solid turns into,
Yes, sir. You were saying something?
basically when we are talking about yes, solid to liquid, when we are talking about melting, so we are only just talking about the name of the state, that from which state to which state the object is actually changing. So in melting, solid changes its states from, or body change its state from solid to liquid. And if we consider its opposite process means in freezing process contains that liquid turns into solid. Yes,
From liquid to
these are
solid.
very general and common process that we already observe in our daily life. So in freezing, liquid actually turns into solid. Further, if we talk about boiling and condensation process, so in boiling, yes, what will be the change of state in boiling? Liquid to gas. Okay.
Liquid to gas.
Yes. So basically in boiling, we know that state change from liquid to gas. And if we talk about the condensation process,
Gas to liquid.
gas to liquid.
So there's two more, right? Solid to gas and then gas to solid.
Yes. Basically, yes, we are talking about basic reaction.
Sublimation,
Yes.
deposition, I think.
But in our physics section, melting, freezing, boiling, condensing, these things are included with the passage of time when we start a new section, because in transfer of thermal energy, there is a concept of a specific heat, latent heat of vaporization or latent heat of evaporation. These type of concepts are included. So these boiling, condensing, freezing, melting are just like the introductory in the first chapter. So these are some process that you know about, that in this situation states of matter takes place over here. And further, if we talk about some different concepts, so let's suppose if we talk about the intermolecular forces, forces and distance between molecules. So let's suppose if we talk about the forces and the distance between the molecules, just like we discuss in solid, liquid, and gases. In solid, we are having a fixed shape, fixed volume, right? So if we talk about the forces and the distance, so first of all, let's consider the solid object. So if we talk about the solid material, so in solid state of matter, you know that particles are
Strong
very close
forces,
to each other. Yes. So they have very strong intermolecular forces.
closely separated.
Yes.
Yeah.
So they have strong intermolecular forces and they can only vibrate about its fixed position. And distance between the molecules are fixed. And further, you know that they have fixed shape, fixed volume, or you can also write rigid shape and fixed volume. And the second state of matter, if you consider the liquid, so in liquids, you know that what about the intermolecular forces? So basically, you know
Uh,
that
how do you
liquids
phrase it?
are,
Because
yes,
it's weaker than solid but stronger than liquid.
yes. So basically, you know that liquids molecules are free to move as compared to the solid one. So basically, the liquid molecules have enough energy that they can overcome the force or that intermolecular forces. So that's why they have weak intermolecular forces because they can move randomly in any direction. So that's why they have weak intermolecular forces, right? So we can say
Right.
that mhm, that in liquid molecules have enough energy to overcome the forces. That's why their intermolecular forces is weak as compared to the solid because they are able to overcome those forces, right? And the second point that vibrate in position for solid. So liquids are not able to vibrate just like the solid. But you know that when you fill any container with the liquid, so still they are very close to each other, not like the gas one that we have to fill gas in a very closed, tightly packed cylinder. We can fill liquid in any open container. Liquid will not flow out from that container, just like the gas. So still they are held close together, not very far away, just like the gases. So they are still held close together, and molecules can move around by sliding over each other. And when molecules move or slide over each other, so this situation allows the molecules to change the shape and to flow, right? And finally, if we shortly talk about the gases, so in gases, you know that molecules have more energy as compared to the liquid to move in random direction with a high speed, so they can easily overcome the intermolecular forces. So molecules in gas have more energy and move randomly at high speeds. So these are some points that helps you to write in the short answers in the theory sections, because sometimes we got stuck that how to write in the different form for different marks. And they can easily overcome the forces holding them close together. They easily overcome the forces or the holding forces, we can say that. And further, they have very large space between the molecules, and we can easily compress the gas, and we can also expand the gas. So there is a process of compression and rarefaction involves in gases. So these are some difference between solid, liquid, and gases according to their intermolecular forces and their distances, right?
Yeah.
And further, if we talk about the concept of the temperature with the molecules, because we are talking about the energies. So according to that, if we compare the temperature or if we relate the temperature with the body, because we already discussed in the pressure chapter that with the help of temperature, the kinetic energy of the molecules will easily increase, right? Because in pressure chapter, there is also a concept of the molecules. So in molecules, we know that when you try to compress the air molecules, so basically they are providing some energy to the molecules, or when you are expanding the molecule container, so basically your volume is increasing, your pressure is decreasing. So all these things we have some basic idea about that. Okay. So basically the amount of pressure that gas exerts actually depend upon the temperature of the gas. Let's suppose if we consider the fixed container, right? And if you continuously increasing the temperature, just like the example of pressure cooker, right? So the pressure will starts to increase because the kinetic energy of the molecule increases with the help of that temperature, right? So again, the same concepts is inclusive in this section also, that is related to temperature and energy of particles. So if we talk about the temperature and energy concept, so in temperature and energy concept, we know that that the amount of the pressure of gas particles actually depends upon the temperature of the gas, right? So basically the amount of pressure of the gas actually depends upon, so it actually depends upon the temperature. Temperature means if you increase the temperature, so basically your
The volume increases.
yes, your
Oh wait,
kinetic
no, the pressure
increases
increases. Yeah.
and your pressure increases. If you allow the molecules to move freely, so then your volume increases. Otherwise, if you consider the example just like the pressure cooker, so basically we are not allowing molecules to move freely or increase volume, so their pressure will increase, right? But since we are only talking about temperature and energy, so basically increasing the temperature will increase the kinetic energy of the molecules. So that's why temperature is directly proportional to the kinetic energy. If we increase the temperature, so the kinetic energy or the movement of the gas molecules or the collision between them will also increase, right? And if we decrease the temperature, so pressure or the kinetic energy will also decrease. We all already know about this concept, right? And basically, let's suppose
Yeah.
consider a specific temperature, right? Because we are talking about always increasing temperature, but is it possible that at certain temperature the motion of the molecules completely freezes? Is there any possibility, or they will not move like just freely
Wait,
like
so what's the question?
question is, let's suppose we are talking about increasing temperature, right? We are talking about increasing kinetic energy, increasing motion, oscillation, vibration. But if we consider the reverse process, that if we are moving towards the negative temperature, decreasing temperature, so is there
Yeah.
any temperature available at which the motion or the movement of the particle will completely or almost equals to zero? It means they will no longer be moving. So
Yeah, there is. Yeah.
so 0 is Kelvin, minus 273. Okay. So basically, that temperature is minus 273 Kelvin, right? That is 0 degree Celsius, because we know that at 0 degree Celsius, we are actually freezing the
Wait,
things.
minus 273 or 273?
Minus 273 on the scale of Kelvin. So if we consider, because in gases, in the situation of the ideal gases or in the section of the gases, we are taking the temperature in Kelvin. So that's why we always have to consider
So
that.
minus 273 Kelvin is minus 546 Celsius.
Yes, because at 0 degree Celsius, we know that water actually freezes, right? But we are talking
Yeah,
about,
0 degrees Celsius is 273 Kelvin.
yes. So that is 0 to 73, the difference of the scale. So basically,
Yeah.
yes, minus 273.
Minus 273 degrees Celsius is 0 Kelvin.
Yes. So let's suppose if we consider pressure on y-axis and temperature on x-axis. So your temperature will be minus 273, which is known as the absolute zero. Absolute zero means, let's suppose if we consider the scale in degree Celsius, or another scale is Kelvin. So basically there are two different scales on which we are working in temperature. This is the normal one, Celsius, that we use in our daily life. And this is the Kelvin. And Kelvin means this is used for the case of the ideal gases, and we when we are working with the gases or some ideal situation in thermal section. So then we have to convert our temperature of Celsius into Kelvin. And if we talk about the numbers, so in numbers we can say that if we consider 0 degree Kelvin, so actually 0 degree Kelvin is equals to minus 273 Celsius, right?
Yeah.
Okay. So basically, the absolute zero, the point where the motion of the particle freezes, is known as the absolute zero, right? And that absolute zero is equals to minus 273 degrees Celsius. Because if we consider them in Kelvin, so in Kelvin, that is actually zero. But if you read that same temperature on the scale of Celsius, so that will be minus 273, right?